Okay, we're on to part B of the question, and it says sketch the curve. And I'm going to say a pre-calculus sketch with some refinements from calculus to do that. And then we'll go to the next thing, which is deduce that either blah, blah, blah. Then say consider blah, blah, blah. And we'll do that one step at a time. I'm going to go to the whiteboard. And again, it's going to give you the document in your possession. I got it right here. I'm going to read the question again. And I want me to sketch a curve. All right, let's do that. And we'll use the pre-calc technique first, by the way. So I say y equals, and this is going to be x squared, and then x minus theta. Right, with the understanding that theta is between 0 and pi. All right, the first thing I would do in a pre-calc sketch is put the zeros down of the function for both the top and the bottom. And again, we're analyzing y at this point. What's the sign of it? Now looking at it, x squared becomes 0 at 0. And the bottom becomes 0 when x is equal to theta. All right, so this will be theta over here. Now again, I know theta is above 0. Right, how do I know that right over here? You're going to take some values over here. Like, for example, after this theta, pick 2 theta. What do you get there? Well, if you square it, you get positive on top. What do you get on bottom? Well, 2 theta minus theta is theta, and theta is a positive number, so that means it's positive. Well, let's go between 0 and theta, and a good value there would be, I don't know, maybe half of a theta. You plug on top, it's still positive. What do you get on bottom? Well, half of a theta minus theta is minus 1/2 of theta. Remember, theta is between 0 and pi, so that'll be a negative number, so I get negative over here. Now, what do you do over here? I don't know, pick a value like, I don't know, minus theta. Plug it in top, you get positive. Plug it in bottom, you get minus theta minus 2 theta. And again, theta is between 0 and pi, so it's a negative number. So it remains negative. All right? So what I do over here, I got an idea that this graph over here, certainly below theta, well, theta is I got a vertical asymptote over there. So vertical asymptote when x equals theta. And write that down. And again, theta is between 0 and pi. So I know I'm getting a vertical asymptote over here. And that's x equals theta. All right? The next thing I would probably do is, maybe just like the y-intercept. Put this over here, y-intercept. And what do? You set x to be 0. And what would that give you? Well, y would equal 0 over minus theta. And again, theta is between 0 and pi, so we're getting 0. So we got something pretty simple there. It's both an x and a y-intercept. All right. The next thing I would probably do is, maybe take a look at limits. So limit as x goes towards theta from the right side of x squared over x minus theta. I got my analysis over here, and I'm looking at it. And if on the right side, I know it's positive. And the bottom's going towards 0, so this is going to be a blow-up problem. So what do I know now from the right? I know this thing is shooting straight up now. All right, let's do it from the left. The limit, x goes to 0 from the left, x squared, x minus theta. And what does that equal? Well, looking at this over here, I know it's negative, and the bottom's going towards 0. Whoops. This is theta. Sorry about that. If you're going towards theta from the left side, and again, this is the line, the asymptote we're talking about, it's going to be negative. And what's happening over here, it's going towards minus infinity, blow up by that. All right? So what else would I do in pre-calculus? Probably the slant asymptote. And how would we do that? Divide through. So x minus theta. It's just a pre-calc sketch, by the way. And that's going to be divided into x squared. Well, what times x will give you x squared? I'm going to say x. What do you get there? X squared minus x theta. Subtract, you get x theta. Repeat. So I'm gonna do plus theta now. What do you get? X theta minus theta squared. I'm going to subtract, you get theta squared. So this function over here can be rewritten y equals x squared, x minus theta, can be written as x plus theta plus theta squared over x minus theta. So I know I have a slant asymptote. I'm just not sure where it is. All right, and I'll tell you why that is. I'm going to say y equals x plus theta. But what I do know about theta, again, theta is somewhere between 0 and pi. So what I'm going to do is I'm over here say that, I'll put theta up here, by the way. They got a slant asymptote that's going between 0 and pi. So I'm just going to put an arbitrary one in, something like this over here. It's got a slope of 1. All right? Now, what do I know about this over here? Well, I know it's going towards it, and I know it's going towards it there. All right, so in a pre-calc sketch, I could actually finish out the sketch now. And this is going to be this over here. I know it's negative there, and over here it's positive. Now, I'm pretty sure you understand that this is a maximal point over here, at least a local max. All right, local max. And there's a point over here which is going to be called the local min. This is where I'm going to go to my calculus. I'm going to take the derivative, and I'm just going to do the first derivative. Let's write that down. So y prime, just going to do the first derivative and try to figure out what's going on here. And hopefully my pre-calc sketch is going to really drive this home, that these local min maxes are to be expected where I think they are. So let's write this down, and we're going to get x minus theta squared. Then it's going to be x minus theta. The derivative of the top is going to be 2x minus the top, which is x squared, and the derivative of the bottom is just 1. Let's just simplify this. You get x minus theta on the bottom. What do you get on top? We get 2x squared minus x squared, which is x squared, minus 2 theta times x. I'm going to factor the top. X comes out. And what do you get over there? You get x minus 2 theta over x minus theta squared. Just going to do some quick sign analysis over here at the derivative. I'm going to, looking at the bottom becomes 0 at theta. All right. And what else do I have on top? The top becomes 0 when x is 0. Oops, 0's over here. Sorry about that. And the reason I know that theta is between 0 and pi, so 0's got to be to the left of theta. And the other place I'm getting a 0 would be at 2 theta. Well, let's just make sure of that. 2 theta minus 2 theta is 0. 0 would give the top 0, and theta would make a 0 on the bottom. Do some simple sign analysis. Like if you take a point over here, I'm going to say 3 theta, and we plug into derivative. That's for x, by the way, and you get 3 theta, a positive number. 3 theta minus 2 theta is a positive number. Yeah, so it's all positive. What does it mean? The function's increasing. It's going up. By the way, I'm seeing that. I'm seeing that over here. It's going up, and I'm expecting the local minimum. It's going to be at 2 theta now. So let's go between this, and I'll say 1.5 theta. And remember, theta is between 0 and pi. So what do you have here? 1.5 theta is positive. 1.5 minus 2 is going to be negative half of a theta. It's a negative number. Bottom's always positive. So this is negative. What does it mean it's going down? So I'm going to say I'm pretty much convinced this local minimum occurred at 2 theta. Let's just plug it into the function and find out what that local minimum value is. And the function, again, is y equals, we'll have to square that. That's going to be 4 theta squared, because the top is x squared, by the way. The bottom's going to be 2 theta minus theta, which is just be theta. So what do you get over there? You just get 4 theta now. All right? Now this one, I think it's kind of obvious, but I still want to go through it. I think it's obvious it's 0, 0, and that's a local maximum. All right? This is a local minimum over here. All right, let me just see if I can do that over here and take a point between 0 and theta. I'll say 0.5 theta. You plug it in, and we're plugging into derivative, by the way. X is 0.5 theta is positive, and 0.5 minus 2 is going to be negative, and the bottom's always positive. I could still get negative. It's going down. Let's go back over here and realize that we're seeing that. It is going down. All right, I'm seeing that in my pre-calc sketch. And over here, I don't know, let's take another number. And let's take minus theta over here as a test point. What do you get? You get negative, and minus theta minus 2 theta is minus 3 theta. It's still negative, and negative times negative is positive. So it's increasing, which is indicating a local max and a local min, as expected, by the way. All right? So I did that. I got a rough sketch, and I got a pretty good idea what's happening in that. All right? I'm going to go back to the notes, and I just graphed it out. I think I did okay graphing it. Again, theta goes between 0 and pi, by the way. So that asymptote's moving around. And so is the slant asymptote, too. The vertical asymptote's moving around and the slant asymptote's moving around. But the curve's going to have that general shape, right? It's going to have that general shape, all right? With the understanding that the minimum and maximum is going to be those values. 0, 0, always going to be there. But this thing does move around. It depends on what theta is. And again, theta is going to be between 0 and pi. All right, what else did they ask me to do? They asked me to deduce. Let's put on what they asked me to deduce, by the way. They asked me to deduce that x squared, x minus theta, well, that's what we just graphed, by the way, is less than or equal to 0. And I'm going to say this is true, looking at the graph, by the way. Let me just go back to the graph. That's true if the x is below the theta. I'll put this over here. So this is true if x is below the theta. All right? So what do I mean by that over here? We're talking about this section of the curve over here. And this section of the curve is always going to be less than or equal to 0 if x is below theta. All right? And the other case over here, we're going to get x squared, x minus theta is greater than or equal to, and again, I'm looking back at the graph, and I'm going to say if we're above theta, it's always going to be above 4 theta. I'll write this over here. And again, that's with the understanding that the x is greater than theta. All right, so I deduced that, and that's what they wanted to deduce. They also said that I should consider something else, by the way. And let's go through that. And I got these parts over here. And, you know, what I'm looking at, I'll be honest with you, what I'm looking at is I'm looking at, you know, sine squared theta, and then it's cosine squared x. I'll put parentheses in this over here. And at the bottom, I'm getting 1 plus cosine squared theta times sine squared x. And they're saying that I should probably like look at this carefully. And maybe I should, by considering the numerator and denominator separately or otherwise show that. Well, let's take a look at this. So I'm looking at, well, what they're saying is that this thing over here is always going to be less than or equal to 1. And what I notice about it immediately, I notice this thing over here, this is always a positive number, right? I have 1 plus something being squared. It's always a positive number, real number system. So it's pretty safe to say that sine squared theta cosine squared x would be less than or equal to 1 plus, I'm just multiplying both sides by the denominator, which is a positive number. And that makes it easy to multiply both sides by this. Now looking at that, I'm going to say that's pretty obvious at this point. I'll tell you why it's obvious. If I were looking at, you know, this thing over here, I was just thinking about it. I mean, this is sine theta cosine x, and that's being squared. And they say it's less or equal to 1 plus cosine theta times sine x, and that's being squared, by the way. So before I say anything, I want to just talk about the numbers that you get from this over here. And we're talking about, you know, the numbers you're getting from this over here. And, you know, the x is going between some values over here. And just, you know, arbitrarily, we have thetas, by the way. So let's just take a look at the sine function and the cosine function. Cosine function, I'm just going to do like, you know, half of a cycle of it. And I get a feel for the numbers over here. They're going between 1 and minus 1. And the sine function looks like this. And what I kind of notice about it is that no matter what combination of numbers I pick over here, they're never going to exceed, the product's never going to exceed 1. Never, all right? And certainly it's never going to go below minus 1 either. So the bottom I'm looking at, it doesn't matter where they are, by the way. I'm going to say that this is going to be true, by the way, because this is never going to exceed 1, and that's going to exceed 1. And over here, you're adding 1 to something, so you're going to get, you know, 1 plus some number. It's going to be some number between 0 and 1, and it's always going to be bigger than this number over here. So I'm going to say that stands to reason, all right? Now what I want to do is I got a couple different things going on over here, and I want to point out, I'm kind of looking at, I'm going to say these two things over here now. And, you know, one, you know, sort of like is greater than, and the other one is less than something. And I want to get them to both be compared to 1 now. So let's write this down. So I get x squared over x minus theta is greater than or equal to 4 theta, right? We already showed that with the graphing it out. And the other thing I'm going to write down is sine squared theta times cosine squared x, 1 plus cosine squared theta, and this is going to be sine squared x, and that's less than or equal to 1. And let's just talk about this over here. The theta here has got to be, let's see, I'm sorry, no, not the theta, I'm sorry. Let me erase this over here. The theta is still going to be between 0 and pi. Now, what do I know about the x over here? The x is going to be greater than, what's it going to be greater than? It's going to be greater than theta. All right, I know that much. All right, and certainly I know 4 theta is certainly a positive number. Right? And the reason I know that is because theta is between 0 and pi. So I'm going to rewrite this as x squared, and then 4 theta, x minus theta. And this will be greater than or equal to 1. All right, so this is always going to be greater than or equal to 1. And over here, this thing here is always less than or equal to 1. My concern right now is for what x values are they going to be in agreement, by the way. Now again, if this is always greater than 1, this reminds me of the problem that we just did in part A, where we had, maximals and minimals, and we're going to just say, when do they touch each other? So we'll set them equal to one another. So we'll put down x squared, and then 4 theta. When are these going to be the same thing? For what value of x will these be the same thing? And let's write this over here. Sine squared theta, cosine squared x, and 1 plus cosine squared theta, sine squared theta. I'm sorry, x. I made a mistake there. Okay, for them to be equal, the only way they could be equal is if they equal to the number 1. That's the only way they could be equal, by the way. So the question comes is, how do you figure that out now? And there's 2 unknowns in it. There's theta and there's an x in it. So what I want to do is I want to probably take an easy one over here. I'm going to take this one over here, and I want to see if I can figure that out. Right? When would that equal 1? And looking at it, let's just write this down. It looks pretty complicated, doesn't it? So let's write this down. So it's going to be 4 theta, x minus theta equals x squared. All right, it looks quadratic in form, doesn't it? So let's write this over here. So I'm going to write down 4 theta x minus 4 theta squared is equal to x squared. All right? And then I'm looking at this thing over here, and it's quadratic, by the way. I'm going to put this x squared minus 4 theta x plus 4 theta squared is equal to 0. Now, I'm hoping it's going to be easy to analyze, by the way. X and x. I'm going to say minus 2 theta minus 2 theta. Let me just check to make sure it's true. X times x squared. Minus 2 theta minus 2 theta is minus 4 theta. Yes, so minus 4 theta x and plus 4 theta squared. So this will occur only when x is equal to 2 theta. All right? And that seems to make sense to me. What are we really getting? We're getting that value that we saw before, the 2 theta thing. Let me just go back and show you that. Right over here. We're expecting that, all right? So let's keep moving. And I know that we got 2 theta now. Now, my problem is I know x is 2 theta, but we really need to figure out what the theta is. Now, there's 2 unknowns here. And let's write this down. So I know this would equal 1 when x is 2 theta. And you can check that out now. So what would you get on top? 4 theta squared. On bottom, what do you get? 4 theta. And then 2 theta minus theta is just theta, which would give you 4 theta squared over 4 theta squared, which would be equal to number 1. But I'm kind of concerned about this over here, and I want this to be 1 too. When is that going to happen? Well, let me write that down for you. That's going to be sine squared. And that's going to be, theta. And going to be cosine squared. That's going to be 2 theta now, right? And let's keep moving. On the bottom is 1 plus, and more difficult, isn't it? Cosine squared theta, and then sine squared 2 theta. Well, time to think, and that's the problem. I mean, solving that equation, I don't think I want to multiply both sides and try to manipulate that too much. And I want to point out, I know theta is somewhere between 0 and pi. And I can't take the endpoint, certainly. So I got to start thinking about in the middle of it, right? Some number in the middle. That's going to make this true, by the way. And let's take a look at it. And I'm going to say, let me take a look at that. I have to think careful about that. I'm going to say theta is pi over 2. Now, let's see what happens. It's in the middle, right? So what do you get over here? I want to see if e equals 1. So what do you get? The sine of pi over 2 is 1, and 1 squared is 1. That was easy. And I'm just checking it out. And if I did 2 theta, right, that would be pi. And the cosine of pi is minus 1, but when you square it, you get 1. Let's go to the bottom. You get 1. Now again, the cosine squared, the cosine of pi over 2 is 0. I don't care about the sine at that point. Oh, look at that. I got that. So what's the theta going to be? The theta is going to be pi over 2. Let me see if I verified that. And I think so. Yeah, we got it. We're done. Thank you.